Okay, can everyone see my slides?
Yes.
Okay, all right. So thank you very much to CASPA for inviting me to speak at the annual conference today. I am very honored. Unfortunately, I cannot see all my friends in person today, but I hope everyone is safe and healthy, and I hope to meet everyone in person very soon. So today I want to share with everyone some of the trends and opportunities that we see in AI and data analytics. And this kind of, reinforces what some of the earlier speakers like Wally and Ingu have talked about. Okay, so there are currently 5 big generational trends that are playing out in our industry. You're probably all familiar with them and heard a lot about them. They're 5G, industrial IoT, hyperscale computing, autonomous driving, and at the heart of them all is artificial intelligence. So these trends are all at different stages, and each will play out over the next several years and have a transformational impact, not only to our industry, but also to our lives. But the most important, exciting part of this is that all of them have semiconductors at their core. So this is, in turn, is driving a lot of design activity and innovation. Both Wally and Ying talked about data as the new oil, right? So there's a saying that AI is the engine and data is the fuel. Today is all about the data, and it's growing at a phenomenal pace. More than 90% of the data that we have today was generated in just the last 2 years. However, most of the data that we have right now is not really being used efficiently. 80% of the data is unstructured, which means that it's not labeled, organized, and it's just sitting in storage somewhere and not being very useful. And only less than 2% of the data is analyzed today. So this means that there's not only tremendous growth in the amount of data, but also a huge untapped potential with all the data that we already have. We can make better use of them. So all the data that we have right now that's being generated needs to be transmitted, needs to be stored, it needs to be processed, needs to be analyzed. So this requires high performance compute, high bandwidth transmission, and high density storage. So a few years ago, people were thinking semiconductors was a sunset industry, but not anymore. So all these generational drivers are creating a renaissance in semiconductors, which calls for the need for a lot of innovation on a number of fronts, including architecture, design, EDA, IP, as well as the manufacturing ecosystem. This renaissance is also driven across the board by a combination of traditional chip companies, many new startups, as well as system companies who traditionally don't develop their own silicon, but they're all jumping into the game, right? They're all building their own customized silicon. This is all very exciting. So the data-centric revolution is driving a lot of requirements and needs for innovation on multiple fronts. Starting with processing, in addition to general purpose compute, there's a need and a movement towards domain-specific and workload-specific acceleration. So FPGAs, DSPs, and ASICs are being used more and more to get the best performance while optimizing for power and cost. On the memory and storage side, systems are becoming increasingly memory bound, and performance is bottlenecked not by processing power, but by access to memory. There's a wide range of options available, and it's all a trade-off really between latency, bandwidth, capacity, and cost. While the traditional architectures are still prevalent, there are some newer ones on the horizon that are very exciting. Connectivity is also a key consideration in hyperscaler designs, and there's an exploding need for very high bandwidth and higher transmission speed, as Professor Stojanovic just talked about. Already, 25.6 terabit switching technology is a bleeding edge, but 51.2 terabit is just around the corner. And as we saw with IR Labs, silicon photonics and 100 gig SerDes are fast becoming the key building blocks of future network infrastructure. On the data analysis side, new innovation is needed to eliminate some of the manual steps that is a bottleneck to efficient data usage today. So let's look at this map of the data-centric cloud infrastructure and some of the players working on the various solutions here. At the top, you see the various hyperscaler cloud providers. I'm sure everybody's familiar with them. And then, the next is a virtualization layer. Below the virtualization layer is where all the hardware sits. Look at data processing. General purpose compute is pervasive, and then that's still primarily dominated by x86, so Intel and AMD. But increasingly, you see more workload-specific engines. NVIDIA has emerged as the main AI platform today, but the future will be a heterogeneous compute pool with more and more dedicated workload-specific engines. Some examples are Habana Labs. They have their Goya and Gaudi platforms, and then Samba Nova with their reconfigurable data units. Of course, there's a lot of startups and design activity in this space, and hyperscalers also are designing their own workload-specific engines. Everybody's familiar with TPUs as well. So all this processing will require a lot of memory. DRAM is currently the workhorse, and HBM has carved out a nice niche, especially in AI processing due to its high bandwidth, but it's very power hungry and very expensive. There's some disruptive innovation coming on the memory side as well. One example is Eli Harari leading the effort at Sunrise Memory with their quasi-volatile memory, or QVM. So the foundation of this at the bottom is the network fabric. This is where it connects all the pieces together and all the data movement happens. And you can see some big incumbents in this area, such as Intel and Broadcom. But you can also see there are many startups really working on disruptive technologies, including fungible on next generation NICs, Innovium, as I mentioned, on the bleeding edge of switches, and companies like IR Labs and Dust Photonics working on silicon photonics. On the storage side, companies such as Xenix Labs and Lightspeed are making next generation storage more efficient. Xenix Labs is working with Microsoft on Project Denali to optimize the workload split for cloud-based storage. And Lightspeed is working on NVMe over Fabric so that you can connect your storage more efficiently to the network. Above and beyond storing the data, many companies are providing solutions to better organize the data. A couple kind of notable recent examples is many of you know about Snowflake. Snowflake just went IPO, was hugely successful. And they do more than just storing your data, but they provide data warehousing where they also organize it for you. Another company is Portworx, which was recently acquired by Pure Storage. They're in a similar space. And there's a lot of companies that are working on innovation to more efficiently label and organize your data. And we'll get into that a little bit later. One important thing to keep in mind is that even though many of these companies are hardware companies, their value is really based on their software stack and their software ecosystem. So an important lesson, especially if you're thinking about doing your chip startup, or maybe you're already in one, important thing to remember is that you can develop good hardware, but you must control the software stack to capture the value. Some of these examples I'm sure you're familiar with. Intel and x86 have a near monopoly in the data center, and that's largely attributable to its operating system and software ecosystem. More recently, NVIDIA's dominance is in AI, not necessarily because GPU is the best architecture for AI, but because of the investment it made in CUDA as a software platform that makes it easier for people to develop their AI systems on. And now you see NVIDIA has replaced Intel as the most valuable semiconductor company in the US. A few years ago, Dell acquired VMware so that it can have access to the full virtualization software stack. And it's putting it ahead of its competition in that regard. Another good example is Arista Networks. So they build networking products, but they use merchant silicon. So there's no differentiation in terms of hardware per se. But they've created tremendous value with their EOS and the full software stack on top of that, including NetDB and their various telemetry and analytics software, so that they can provide their customers the ability to closely monitor and manage the network traffic that's flowing through their network. And that creates a lot of value. SambaNova is a more recent example. They build AI systems. And as I mentioned before, they provide the entire system solution for AI acceleration, including hardware and software. So the most recent announcement, their system, their RDU has 5x the performance of the competition right now. But more importantly, they have future software upgrades that promises significantly higher performance on top of that, even though it's running on the same hardware. So let's take a closer look at some of the challenges that we have with data today. The current AI systems require massive labeled data sets. If you want to build an AI system to tell you if your picture is a cat or a dog, you have to train it with thousands and thousands and thousands of pictures of cats, dogs, rabbits, or whatever animals, right? And they all have to be labeled correctly. And only after you've trained your system through multiple iterations, then you can feed it a new picture and it will try to tell you if your picture is of a cat. And so all those pictures have to be labeled in the training set, and that is very manually intensive and very error prone. Similarly, once you have all this data, managing your database and creating the analytics workflow currently require a lot of manual intervention from a very highly skilled, highly specialized person, right? And they're very expensive, and there's very few of them, and this creates a bottleneck. So as a result, most of the data today, as we talked about earlier, is really not fully utilized. So let's take a look at some of the innovation happening here. So this is a map of on the left-hand side is a map of the various stack of how data is generated at the bottom, how it's managed in the middle, and then analyzed at the top to drive business decisions. As you can see, there are multiple manual steps, right? You see the ones where it had people on it. So there's a manual step before the data enters into the data management system. And then there's another manual step to set up the analytics. So on the right-hand side, I highlight some of the startups actually providing some innovative solutions across these various layers. Starting at the bottom, so Snorkel is an interesting company. They automate data labeling process. And so they use heuristic functions to label the data in real time as they're being created. Katana Graph uses graph analytics and graph pattern mining so that they can operate and analyze data directly in storage, so they can operate on unstructured data. AutoTune helps you tune your database management system. So currently, again, your DBMS is being managed by a specialist, right? And they manually tune the various configurations in your DBMS, hundreds of parameters to fine tune the performance. And this now can be done with AI and a predictive model. So if you use AI and it uses your previous performance results, and it can predict the future performance, and it can automatically tune your system for you. Data Chat and Ursa Compute are working on different solutions to really automate and simplify the generation of the data workflow. Data Chat uses natural language. So instead of having a data scientist program in Python or whatever other language to create your workflow, you can just have a layperson answer a number of questions using natural language, and the system will provide the workflow automatically based on your answers. Ursa Computing is working on creating a set of libraries based on Apache Arrow that will simplify the way that you access and prep and analyze your data. At the very top, we have Inferencio that's using AI to really do automated diagnostics and predictive modeling, so that, to help in your business intelligence. So you can make, not only analyze what the data, but actually based on the analysis, make smarter business decisions. So data and AI have really enabled digital transformation in many traditional verticals. I list 5 main ones here that I'm sure you're all very familiar with. And AI is playing a big role in all of them already, and will do so more in the future. So one that everyone, I'm sure, is very keen on, and let's take a closer look at, is medical and healthcare. For medical and healthcare, obviously big players such as Apple and Google are investing heavily not only in AI ML capabilities, but also ways to generate and manage a lot of consumer healthcare data, right? For example, if you're wearing an Apple Watch or some other type of wearable, or even on your phone, it's collecting a lot of data and is driving your health going forward. There are also many startups that are applying AI ML in innovative ways across healthcare. I'll provide a few examples here. To start with, InSitro is founded by Stanford professor Daphne Kohler. She's a McCarthy Genius Award winner and co-founder of Coursera with Andrew Ng. InSitro is using AI machine learning to help drug discovery. It helps researchers identify new tests and potential therapies to try out. So currently, only 5% of drug discoveries are successful, which makes drugs themselves and the development process very expensive and very time-consuming. So if technologies such as InSitro can significantly improve the odds of successful drug development, the value monetarily and as well as societal are huge. Similarly, another example, Berkeley Light is a company founded by the name Berkeley team, and they recently successfully IPO'd. They use optofluidics and AI to isolate and move T cells for patient-specific treatment. In the future, instead of a generic drug that has 75% efficacy across the population, we can individualize treatment for each patient. Berkeley Light's Beacon platform is currently used to target cancer treatment, immunotherapy, and most recently, COVID-19 treatments. Lark is another company that's using AI ML to help patients. They provide scalable care for chronic disease patients, so people with diabetes and hypertension. These patients don't usually need acute treatment. What they need is long-term monitoring and fine-tuning of their care based on their vital statistics. And using AI ML for automation is ideal here. Another example is LVIS. This is another startup from Stanford. What they do is use AI and image recognition to monitor your brain activities, and that can help predict as well as treat neurological disorders such as epilepsy, Parkinson's. Okay, circling back to Cadence. So what role can Cadence play in all of this? So Cadence has recognized that these industry trends can be very well leveraged through our computational software expertise, and we have outlined our strategy called Intelligent System Design. It starts with design excellence. That's our core business, to deliver leading edge EDA solutions. And all these design activities picking up due to the mega trends means that there's still plenty of growth in this area. The next layer is system innovation, where we expand beyond silicon to deliver complete system solutions to our customers. This includes hardware, software co-development, as well as going beyond the chip and looking at system level, including non-electrical integration and analysis. The third layer is pervasive intelligence. We are building AI capabilities into our existing solutions. Furthermore, we're building AI and data platforms to enable customers to address specific vertical markets. So most people are probably familiar with Cadence as an EDA company, so I won't focus much on the design excellence part. I'll give a little bit more color on system innovation and pervasive intelligence. So Cadence's system innovation strategy focuses on system level integration and analysis and software and hardware co-development. We have moved into this space with a combination of internal development, strategic acquisitions, and partnerships. For example, we released Clarity EM Solver and Celsius Thermal Solver last year as new products, and both with significant performance advantage over the competition. Both of these tools are fully internally developed. On the acquisition front, last year we acquired AWR and Integran to expand and enhance our RF system design and analysis capabilities. Also last year, we formed a strategic partnership with Greenhill Software, a leader in embedded operating systems and software security. We are collaborating on embedded system security and software hardware co-bring-up and co-validation. So this is still a new area for us, and there will be a lot more to come in this space. For pervasive intelligence, Cadence has what we call ML Inside. This is where we add AI capabilities to our existing tools. This is transparent to the user, but customers see significantly better results every time you run the tool. We also have what we call ML Outside. This is an intelligence layer on top of our tools. And this will either help you recommend your next run or automate your runs so that you'll require fewer iterations to get the same or better results, significantly improving your productivity. On the IP side, we have an AI accelerator, such as a DNA 150, which complements our Tensilica DSP platforms for vision and audio. And longer term, we are working to build AI and data platforms to enable our customers in specific verticals. Okay, that's the conclusion of my talk today. I hope it was informative. And thank you again for having me, and I hope everyone stays safe and healthy. I'll be happy to take a few questions if time permits.
Thank you, Renxin. One question from the audience is, AI and data analytics are two types of workloads. NVIDIA are solving both problems with GPUs, but may not be the most efficient. Are we going for more domain-specific architectures or consolidation of the architecture for these workloads?
I think there will be a move towards more domain-specific workloads. You know, and to be frank, I mean, I think all the hyperscalers really are the ones controlling the data and the workloads. So, you know, I know there are a lot of AI startups out there, and, you know, they claim to have the best architecture, or they have the best performance, or tops per watts, those type of metrics. That's not very useful unless you can really get your hands on a real set of workloads. So you either have to have it yourself, or you're part of a vertical and you're building your own data and workloads, or you have to partner with one of the big guys, and they if they can share with you their data and their workloads, then you have a much better chance